Okay, so let's take a look at how we can make this happen. I think the pretty obvious thing is we need to create a view instance somewhere. And we can directly pass L into it because, yeah, that's the same thing. And then model obviously should be passed into the data. So let's make it reactive. And then view. So view is a function. View is a function that takes 3 arguments. And because view is essentially the render function, what we need to do is call it inside our render function. So we're essentially returning the view that's generated from our view function. And the first argument is obviously the h, and the second argument is model. So we can, because model is made reactive here, we can actually directly pass it in if you want to. And really the last question is, how do we create this like actions thing, right? Directly passing actions probably does not work, right? Because if you pass it here, the click, when you pass it to click, this will be called with the DOM event as the argument instead of what you expect here, which is our model essentially. And we also need to collect the return value from these actions in order to somehow trigger state updates. So it's pretty, so we realize that we cannot just directly pass the same actions object into our view function. Instead, we need to maybe, you know, like wrapped actions or something. And this wrapped actions will contain the same keys as the original actions object, but the implementation will be different. So what we can do is, let's make wrapped actions an object, and then we iterate through the incoming, the source actions. Right? And wrapped actions key equals something. So now we can think about how they're expected to work. They should receive the incoming, receive the current state. So they should be, oh, wait, sorry. Wrapped actions, let's just make it a function first. Think about what it should do later. And these arguments, so this argument is actually what we receive from the click event. So for us, that's really not useful, so we can just ignore it. What we care more about is that this function is called, okay? And we will probably want to save the original action somewhere. So when the wrapped action is invoked, obviously it should call the original action. And our original action expects the model, so we pass the model to it. And the original action returns the next model. Right? Now comes the interesting part. How do we take the next model and somehow make our state reflect what's going on? So what we can do is, in fact, I think we should probably do something like this model, like this. Const app. Well, let's call it VM. Okay. And we want to reference the latest model here. And vm.model equals the next model. So this could probably work. This is, I believe this is slightly different from our reference implementation, but just for the sake of it, we should probably give it a shot. See if there are any errors. No errors. And yeah, it works. So we've successfully satisfied the API requirements that we see in the exercise. So let's recap. The first thing we're doing is we have, so the thought process is actually in reverse. We first start thinking about the top level requirement is we need to create a view instance and mount it to L. This view instance should take the incoming model and make it reactive. And then inside this instance's render function, it'll invoke the view function and pass it the necessary arguments, which is the H, the model, and actions. Then we realize the incoming raw actions will not satisfy our requirements, and we somehow need to essentially map the original actions to another version of it to satisfy the API requirements. So we create another cloned object and then essentially create these mapped functions. And inside these mapped actions, we will call the original action, feed it the current model to retrieve the next model, and then we replace the current model with the next model. So as you can see, internally this is still sort of mutating stuff, but what we expose to the external is purely functional. It's in fact, you can see that this whole app doesn't contain any mutation in any place. Everything is just functions, arguments in, arguments out. And the point of this exercise is really to show that despite the superficial difference, so when we talk about like going for a more functional style or a more whatever style, it's more important to understand the underlying connections between different paradigms. Similar to JSX versus templates, or functional versus non-functional. I believe the most important thing is to understand what problems are they trying to solve, instead of just sticking to one thing and believing it's better than the other. So Pete Hunt, who's he worked on React very early on, he recently had a tweet which I liked a lot. He says, the things that you like are probably not as good as you think. The things that you hate are probably not as bad as you think. So I think it's important to always keep an open mind when you see, confronting paradigms and it's always worth for the other side and to understand the benefits of both. That'll help you even if you don't switch, that'll help you understand the underlying problem better. Okay, so we're done with state management. Do people want to take a break? Are you tired? Okay, I guess we'll move on then. So going back to our slides, routing, and this slide doesn't really say much. So routing, how many of you have used the view router? Okay. How many of you have used a router of sort in another framework? Okay, great. So I guess most of us know what single page application routing is all about. You have URLs, you want to map them to components. That's the gist of it. So we're going to talk, so the goal of these exercises is really about going from the ground up and see how it can be done in the view context. So let's go into the first exercise in routing. And it's, let's build a very extremely simple hash-based routing solution. It's not even a router, it's just routing with using direct browser APIs. So we all know that in the browser there are two ways to do routing. You can use the hash or you can use the HTML5 history API. So HTML5 history API is better in the sense it supports like pop state and you get better looking URLs, but it requires some sort of server configuration so that when you directly visit a deep link, the server still renders the same static HTML page for your client-side router to pick up. So for the sake of exercise, we're just also the history API is a bit more complex than a hash API to work with. So for the sake of the exercise, we're just going to stick to hash routers. Because aside from the browser API differences, the underlying implementation is really the more similar and more important part. Our goal is to build a small app that when the hash is foo, it should display foo. When the hash is bar, it should display bar. Simple as that. The two APIs you can use is if you want to access the current hash in the URL, use window.location.hash. If you want to listen to hash changes, you can add a listener, hash change listener to your window to listen for changes. And the template is already written out for you. You need to figure out what to fill in here. This is where our main view will be rendered. We provide 2 links already. And yeah, the rest is up to you. So let's do it. Let's give it 10 minutes. Can you freeze the screen?